All right, so here's a question from my messages that we didn't get to during today's real-time class session, so I'm just going to run through it with you on this video. What we have here is a linear inequality in one variable, x, and what we want to do is isolate the variable, and then we'll turn the resulting statement into interval notation. So to isolate the variable, it means we want to get the variable x all by itself on one side of this inequality symbol, which is a less than at the moment, and a number on the other side. So the first step will be to get all of the terms that have an x on one side of the inequality and all of the constants on the other. So you'll have an x term and a number. I think I'm going to make the left-hand side of the inequality the side that has the x terms. So I need to get rid of this 6x, which is the x term on the right. So it's being added. So I am going to get rid of it by subtracting. And plus 6x minus 6x, that's 0. And if I subtract 6x on one side, I have to subtract 6x on the other side as well. Since the x's are going on the left, the constants are going on the right, so I need to get rid of the minus 11 on the left, which I do by adding 11. Minus 11 plus 11 is 0, so that's going to go away. And if I add 11 on one side, I have to add it on the other side as well. So what I end up with when I do this is 17x minus 6x is 11x is less than 2 plus 11 is 13. And now I just have to cancel the coefficient on x by dividing. So 11 divided by 11 is just 1. So I'll get a 1 times x is x on the left, and dividing by 11 on the other side as well. We see that our solutions are the values of x that are less than 13 over 11. We'll turn this into interval notation in a moment. But I just want to show you what happens if I decide instead to move the x's to the right instead of the left, because that is also valid. So I would do that by subtracting the 17x on both sides. That'll cancel this 17x on the left. And on the right, I will have negative 11x. Since now the x's are going on the right, I need to get rid of the constant on the right. So the constants will be on the left. So I'm going to subtract 2. So that'll become 0. And I get negative 13 on the left. So now I have to divide by the coefficient on x, which in this case is negative 11. So here's the trick, and this is the complication that shows up for inequalities that does not show up for equations. When you divide or multiply, in this case dividing, by a negative number, the inequality symbol changes direction. So this turns into negative 13 over negative 11, which is 13 over 11, is greater than x. But these two statements are actually the same thing. X being less than 13 over 11 is the same as 13 over 11 being greater than x. So we do get the same set of numbers as our solutions, whichever way we choose to do this. So now let's look at turning this into an interval. I tend to like to draw it on the number line first. So I'm going to draw my number line. I want all the numbers less than 13 over 11. So here's 13 over 11. I want everything smaller than it, so that's numbers get smaller to the left. So I'm going to get everything to the left of 13 over 11. And this endpoint is not included because it's a less than, not a less than or equal. So I get an open circle here, not a shaded in circle. So that's what it looks like graphed on the number line. And once you have it graphed on the number line, it's really easy to turn it into interval notation. Because I look, what's happening on the left? Well, it's going on forever on the left. It's getting infinitely small. So our left endpoint is negative infinity. And our right endpoint, where it ends on the right, is 13 over 11. And the endpoint is not included, so we get a paren as opposed to a square bracket. And our answer in interval notation is that the solution to this inequality is all the values on the interval from negative infinity to 13 over 11. And so I hope this helps.